Okay, everyone, welcome to the Intro to IPUMS GeoMarker webinar. My name is David Van Riper. I'm one of the co-principal investigators on this new NIH-funded product from the Minnesota Population Center and IPUMS. And today I am here with my colleague, Tracy Kugler, who works on the project. You may hear her voice during the webinar as she asks some questions. So I was going to let Tracy introduce herself.
Hi everybody, this is Tracy Kugler, also at IPUMS and working on GeoMarker and other geospatial aggregate data projects here.
Great, thanks Tracy. And in the chat room you may see the name of another person, Jonathan Schrader. Jonathan is a research scientist here at the Minnesota Population Center who works on GeoMarker and NHGIS and the geographic aspects of some of our microdata products. He and Tracy will be monitoring the chat and the Q&A boxes during the webinar, trying to answer the questions as I talk. I'll be focused on the presentation and they will be answering the questions. But I want to welcome you to the second in our IPUMS webinar series. 1 month ago, Jonathan gave a webinar on IPUMS NHGIS, which is a sister project to IPUMS GeoMarker. I'm presenting on GeoMarker today, and we will be continuing our webinar series throughout the spring semester with hopefully having one on our IPUMS USA microdata product in late January. But I'm going to go ahead and jump into this talk, and we'll spend the next hour or so going over this new product that we're excited to present to you. So for today, in terms of the plan, I'm going to do a quick overview of what is IPUMS GeoMarker. Then I'm going to do a walkthrough of the user interface that we've built for the product. We'll talk a little bit about what the output data looks like, what comes out of GeoMarker. Talk about some tips and tricks related to the product, and then at the end we'll save time for a Q&A session. If any of you have questions, feel free to type them into the Q&A box or the chat window, and I can answer those at the end of the webinar. IPUMS GeoMarker is funded by the National Institutes of Health, and it's a joint project between the University of Minnesota and the PIs on the University of Minnesota and our J. Michael Oakes in the School of Public Health and myself. And our partner is at Texas A&M University, and the PI on the Texas A&M side is Dan Goldberg, who's a professor of geography and director of the Texas A&M University Geoservices Center, and they are providing the geocoding services that I'll be talking about today. At the most fundamental level, GeoMarker essentially is a platform where you, the user, provide data, you upload it to the GeoMarker platform, we do some processing on that data, and we provide it back to you as what we're calling enriched user data. And today you're going to see how that works and exactly what that enrichment process looks like. We provide two different types of enrichment. In the first method, you may already have individual level data with latitude and longitude coordinates attached to it. And you may want to assign some census characteristics to each of those point locations. In this case, you can upload a data file with the latitude and longitude coordinates to GeoMarker. GeoMarker will convert those latitude and longitudes to points, overlay them with census tracts, attach selected census characteristics to each record, and then create an output CSV file that you can then download and analyze as you see fit. The second workflow that GeoMarker supports is if you have collected a set of addresses for a survey or for some other research project, you can upload those addresses to the GeoMarker platform. We will geocode those addresses using the Texas A&M University geocoder. We convert those to points, overlay with census tracts, attach the selected characteristics to each record, and again create a CSV file output that you can analyze. Now, before we go on to the workflow and a demonstration of the UI, I want to talk just a little bit about what geocoding is. Now, many of you who are here for the webinar may have done geocoding before, but for those of you who haven't, the main goal of geocoding is to convert a text-based description of a geographic location to geographic coordinates that pinpoint that geographic location to a point on the Earth. So in terms of the textual description, an address may be written as 630 8th Street Southeast, Minneapolis, Minnesota, 55414. A geocoder will standardize and parse that text string. It will compare that to a reference data set, and it will return geographic coordinates like you see at the bottom of this slide, where that address actually refers to 44.988 degrees latitude, negative 92.242 degrees longitude. Once we have those geographic coordinates, we can then overlay them with census units and attach the census characteristics to each of those coordinates. The geocoding process, at its most basic level, it's a process of standardizing and parsing the input addresses that you've collected. Select a matching feature reference. For example, a feature reference could be an address point, it could be a parcel, it could be an address along a street segment, it could be a zip code centroid. And finally, we determine the latitude and longitude for that point based on the link between the standardized address and the matching feature reference. Now, we could spend the entire webinar talking about the ins and outs of the geocoding process, but today I want to focus more on how to use the GeoMarker user interface and what it can do for you as the user. We're considering having a follow-on webinar at some point in time talking about more of the details related to the geocoding process. So now I want to show you what we've put together on our GeoMarker website and do a couple of walkthroughs showing you how to use this product that we're excited to debut today. So I'm going to go out and go to the main website. The main website is geomarker.ipums.org, as you can see here. And I'm going to walk you through our static site first, and then I'm going to talk about, and then I'm going to do two walkthroughs of our user interface. One uploading point location data where you already have latitude and longitude coordinates, and one walkthrough where you're uploading address data that you need to geocode before attaching census characteristics to each record. So here on the static site, I want to point you to the left-hand menu. We have a number of headings, and the top one is our data heading. And in particular, I want to draw your attention to the bottom option, the preparing input data. If I click on this, this shows you how to structure the text files that you will be uploading to the GeoMarker platform. And this takes you through how to structure a CSV, a comma-separated value file, if you already have latitude and longitude coordinates, or if you have addresses. Here at the bottom, it shows you what fields we expect in your comma-separated value file, and an example of what that looks like here at the bottom of the screen. For documentation, we have three headings. Our contextual data heading provides details on the ACS, the American Community Survey-based contextual variables that you can choose among. If you scroll down on this page, you can see the variable names, for example, proportion unemployed, the source table that we draw that from, the universe, the numerator for the proportion, and the denominator. And so you can come back here and see how we've defined the variables that you can choose among. The geocoding page provides more detail on the geocoding process and how to interpret the output related to the geocoding process. It also provides more detail on the Texas A&M University geocoder and the various data sets it uses for feature matching. And finally, the third tab underneath documentation is security and privacy. We take data security and privacy seriously here at IPUMS. And for this project, we've partnered with the University of Minnesota's Academic Health Center to house the GeoMarker platform within its secure data enclave. The data that you upload to the system are encrypted from your computer as they're transferred to GeoMarker. We also encrypt the data transfers to and from Texas A&M University if you're doing the geocoding of the addresses. And finally, we only retain the data extracts that are the data that are produced for 14 days. After that time, we delete the data files from our system so that there's no concern on the user end about whether or not those data are sticking around for a long time. If the process fails, if the geocoding process or if the point location overlay process fails, somewhere during execution, we purge all of the data files and all of the database tables that are created during that process so that there's no remnants of the user-provided data on our GeoMarker platform should the system fail. The other sections on the static site, project, research, and support, provide some more information about the project, and the help option at the bottom of the page provides you with our email that you can use to get user support. If you're having trouble with the system or if it doesn't seem to be doing what you're expecting, feel free to send an email to geomarker@umn.edu, and we'll get back to you as soon as possible to try to help troubleshoot the problem that you're having. So to get started using GeoMarker, the easiest way is to click on I'm going to go to the home page. The easiest way to start using GeoMarker is to click on the large Get Data button. To use the large Get Data button here in the middle. So now you're into the GeoMarker platform, and you can see there's two possible paths you can choose when you come into the page. You can either choose the point locations or the address data path, and I'm going to show you both of those. We're going to start with the point locations path. This is the workflow that you would use if you already have latitude and longitude coordinates for each record in your data set, and you want to attach census characteristics to those. So if you click on the icon, the triangle icon, there'll be a pop-down that opens that will show you how to structure the CSV that you're uploading. The latitude and longitude coordinates that we expect should be in WGS 84. If you have coordinates in a projected system, such as Albers or UTM, it will produce erroneous results. So we would really like it. At this point in time, we require that the data are in WGS 84 coordinate system, and the CSV format should be as you see here on the screen. You have one column with the unique identifier that you can use to link back to your original data, a column with the latitude values, and the column with the longitude values. We recommend that you not include any other data describing the respondents or the individuals that are in the data set. You should retain those data on your own system and use that unique identifier to link it to the locational data that you're getting from GeoMarker. So if you just want to test out the system, if you don't have data that you're ready to use, we've provided a sample point location data set that you can download, and so I'm going to use that for the example walkthrough today. So I'm going to simply click on the Try GeoMarker using sample point location data, and it's going to download the CSV file to my screen. And if you're wondering what that CSV file looks like, I'm going to show you right now. As you can see here, there are 9 records in the data file. There's a case ID, a latitude, and a longitude for each record. And that's the file that's going to be uploaded to the GeoMarker system that I'm going to demonstrate right now. I click on the Go button to move on. And now you're taken to the login system. So we require you to log in at this point in time to use GeoMarker. Now, if you already have an IPUMS account, if you have an account with any of our existing IPUMS data products, you can simply type in your IPUMS email address and password here, And when you go to sign in, if you are not a registered GeoMarker user, you will be redirected to the page where you agree to a few user agreements. And once you've clicked on that, you'll be registered and you can use GeoMarker. If you've never used an IPUMS product before, we have a create an account option here on the lower right-hand part of the screen where you can create a new account. And this is, again, this is only for users who do not have an IPUMS account. I'm going to click on that now to show you what that looks like. And then I'm going to come back and I'll log in using my own username and password. So I'm going to click on create an account. And what you need to do is you provide an email address and a password. You enter that twice. We ask for first name, last name, and institution, occupation category and title, what field of research you're in, and a general research statement. You know, what are you hoping to use GeoMarker or another IPUMS product for? And then at the bottom here, we have 4 checkboxes that you have to click on affirmatively and that you agree to our terms of use. And those terms of use are redistribution. You will not redistribute the data without permission. 2, you will cite IPUMS GeoMarker data appropriately in a publication or a research report. 3, you agree to use IPUMS GeoMarker for scholarly research and educational purposes only. Commercial use is prohibited. This product is really meant for research purposes. We don't want users to just be geocoding data that they're then reselling or using to generate income. It's really a product meant for research purposes, and that's what we're pitching it for. And the final checkbox relates to PHI, or public health information, or personally identifiable and protected health information, or personally identifiable information. And if you're submitting any information to the university that is PHI, as defined by the Health Insurance Portability and Accountability Act of 1996, and its implementing regulations, you represent that you have received the appropriate authorization as required by HIPAA. You have a waiver of authorization from an IRB for such PHI, or you're submitting a limited data set for the purposes of research, public health, or healthcare operations. Once you've clicked affirmatively on these 4 checkboxes, you submit at the bottom of the screen. You will receive an email to your inbox where you click on a link to verify that you are who you say you are. Once you've verified, you can actually start using the IPUMS GeoMarker product. I'm going to go back and just log in with my own email address now and walk you through the system. So I'm going to log in with Van Riper. Geog, type in my password. I'm going to sign in. So this is the first page of the user interface. This is where you provide the CSV file that you want to enrich. I'm just going to go ahead and drag and drop the CSV that I downloaded, the sample input points, onto the box. The next step in the process is you have to select the columns from the uploaded data that match the following. Which column is the ID field, which column is the latitude field, and which column is the longitude field. You click on the triangle icon and you'll see the column headers that were in the data file that you uploaded. So in this case, the ID field is case ID, latitude is latitude, and longitude is longitude. Now that I've selected those 3 columns, I can go on to the next icon up here in the upper right-hand corner. The next step in the UI is to choose the geographic level for which you want census data. So right now, IPUMS GeoMarker provides contextual data for census tracts only. We'll be expanding the geographic, and right now we only provide that for the 2016 American Community Survey. We'll be expanding our set of geographic levels and years in the future. But at this point in time, we haven't decided what we are going to add, and we'd love to get feedback from our users or the people on the webinar here about what you would want. What are other geographic levels, such as cities or metropolitan areas or counties, that you're interested in? Are there other years of data that you're interested in getting from IPUMS GeoMarker? Feel free to write us at our email address or type in the chat today to let us know what you're interested in. I click on the next icon up here in the upper right corner, and now I can move on to selecting the contextual variables that we've computed at the census tract level that will be linked to the output data. And the way that we came up with these 10 variables are that Tracy did a literature review in public health, in the public health literature, looking at the neighborhood effects. So looking at neighborhood effects papers and what were the most commonly used contextual variables from the census that they included in their research. And these are the 10 that we've identified that are commonly used, so we decided to start with them. Again, if there's things you're interested in, please let us know what you want. Now, you need to select at least one of these variables. You can select 1 up to 10. I'm going to go ahead and select the first 6 of them off the list here. I'll move on to the final page, which is the submission page. Here, I'm going to type in a data extract name, webinar test, December 7th, 2018. And I'm going to type in a description for what I've selected. Selected 6 ACS variables for the sample input points. At the bottom of this page, you'll see a summary of the selections that you've made. So your geographic level, the contextual variables that were selected, and we support one output format. We currently only provide data as a comma-separated value file, but that file is easy to read into either a GIS program or Excel or a statistical package that you may use. And finally, you click on the green Submit button to submit the extract to the system. I'll do that now. Here, this is our extract history page that we've put together. You can see here the top record is the extract I just submitted. And you see we have an extract status column that changed from queued to in progress. And so right now it's converting those 10 or 9 points from a text file into a spatial data set. It's overlaying those with the census tract polygons in a post-GIS database. It's then attaching the census characteristics based on census tract ID, creating the CSV file, and finishing. So now if I click on the download button, I will actually download the zip file that contains a codebook and the enriched data file that I've just created. Now, I'm going to show you what those outputs look like in a second, but first I want to go back and just do a walkthrough of the geocoding process, the geocoding workflow, just so you see what that looks like and how it's actually very, very similar to the point locations workflow. So to start over again, I go up to the top and I click on the Get Data link that's on the upper banner of the website. I'm taken back to the workflow, the initial page, the workflow page. I'm going to show you, in this case, the right-hand pane is for address data. So I can click on the triangle icon to see the address location format that our system expects. We expect a 5-column CSV, an ID, an address, the city, the state, and the zip code. And I want to let you know now that currently, and what we expect in the future, is that GeoMarker only works for US addresses. The Texas A&M Geocoder supports US geocoding only. So if you're working with address data from a non-US country, GeoMarker will not be a product that you can use. Again, we've built a sample data set that you can test with if you just want to learn how to use the IPUMS GeoMarker geocoding workflow. I'm going to go ahead and click on that to download it. And let me show you what that data file looks like right now. This is the 10 addresses that we will be geocoding. You can see we have a column called Unique ID. We have an address, a city, a state, and a zip. And these are what the system will be geocoding here in a second. I click on the Go button here to start the process. Now, because I was already logged in from the point locations workflow, I did not have to log into the system again. So I'm going to drag and drop the CSV file into our drag and drop pane here. Now I need to select the columns again from the uploaded data that match the following. And this is really where the difference is between in terms of the workflow between the point locations and the geocoding workflows, is that the geocoding workflows ask you to match a different set of columns. So I'm going to click and select the unique ID as my ID field, address as my street address, city, state, and zip. So it's not a complicated user interface. It's not hard to choose these columns. This is really probably the most onerous page you have to make decisions about. Going to the geog levels, again, we only currently support the 2016 ACS census tracts. So I'm going to go ahead and click next to move on to the variable selection. I'm going to choose the bottom 4 variables that I didn't choose last time: the proportion African American population, the proportion of adults who completed high school, persons per square kilometer, and housing units per square kilometer. Click on the next button up here in the upper right to move on to the final page. I'm going to give it an extract name, Geocoding Webinar Test, December 7th, 2018. Geocoding the sample data set. Again, you can see at the bottom we have a summary of the selections that you made. I'm going to go ahead and click the green submit button to send it on to the system, and it's now creating the data extract. Now, if I had uploaded a large data file at this point in time, I may not want to wait around for the file to get processed. So you should know that when the data file is created and ready to download, the GeoMarker system will send you an email with a link to your extract history page, and that will take you to this particular website where you can then click on the download buttons to download those data files. So now I want to look at what the output of GeoMarker look like, just to orient you to what the data files actually look like. So I'm going to download my point location zip file first and show you what the two data files in the zip archive look like, and then we'll look at the geocoding one as well. So I click on the download icon, and I downloaded a zip file. In my case, this is geomarker_1077.zip. I'm going to click on that link to open the zip archive. There's a file folder, geomarker_1077. I open that, and you'll see there are 2 files in this zip archive. One is codebook.txt, and one is a CSV file. The CSV file contains the data that you're going to want to analyze. The codebook describes the contents of that data file and describes the process that was used to generate that data file. So I'm going to start by looking at the CSV first, and then we're going to come back and look at the codebook just so you can see what that looks like. I'm going to double click on the CSV to open it, and then I'm going to zoom in a little bit here so it's easier for you to see. I'm going to select all of these columns and make them a little bit easier to see. So to orient you, and I'm going to walk you through what these columns represent. So the first 3 columns in the data set are what you uploaded to the system. So it's the case ID, it's the latitude, and the longitude that were in that sample points data set. The next columns are the columns D through I. Those are the geographic identifiers that were linked up to your data when we did the spatial overlay, where we overlaid the points represented by the latitude and longitude coordinates with a census tract shapefile, and we assigned the geographic identifiers from the census tract that those points intersected with. So we have a state and the name of the state, we have a state FIPS code, we have a county name, we have a county FIPS code, and we have a census tract identifier. And then you see this GIS join value here in column D. The GIS join is a unique identifier for each census tract. It's something that we created as part of our IPUMS NHGIS data product. So if any of you are familiar with our NHGIS data, anytime you download an extract from that system, you get a GIS join in the output file. And that is the identifier that you can then link up with the GIS join field in any of our NHGIS shapefiles. So that's the kind of the unique linking key for the data. Finally, from column J, in this case, to column O, these are the census characteristics that you chose in your extract. And so up at the top here, you'll see that we have variable names GM001 underscore 2016, GM002 underscore 2016, etc. And then underneath it, you have some proportions. And so we decided to assign arbitrary variable headers to the columns. And those are described in the code book that we'll look at in a second. So you can figure out what does this GM001 underscore 2016 actually represent. That is in the code book file that comes with each extract that you download. So now let's take a look at that code book and give you a sense for what we have there. So this is our code book file. It's simply a text file. It's broken up into 5 parts: a data summary, a data dictionary, a description of the contextual variable source data, a description of what the point and polygon process is that we use to assign a census tract ID to each point that you've uploaded, and then some information on citation and use of the data. And the key part here that I want to immediately draw your attention to is the data dictionary. So if you scroll down to the data dictionary, you'll see the top section deals with the geographic unit identifiers that I just described: the GIS join, the state, the county, and the tract. And then underneath that, you'll see the contextual variables that you could have chosen and that you may have chosen in your extract. So here you can see that variable GM001 underscore 2016 represents the proportion of the census tract that is unemployed in the 2012 to 2016 ACS data. GM003 is the median household income for 2016, and down at the bottom, GM10 underscore 2016 is the housing units per square kilometer. Now, if you keep scrolling down in this code book, you'll see the information about how we computed each of those contextual variables. You'll see the source data set that we used, the source table that it comes from, the universe for that table, and then finally the numerator and the denominator that goes into the computation of that proportion. So you could go to the American Fact Finder or to NHGIS. You could find this source table and download it and check our work if that's something that you want to do. So going back to the data file, we can see that for record 1, we have the latitude and longitude, and in this case, it falls within Ramsey County, Minnesota, tract 41105. In that census tract, for example, the median household income in the 2012 to 2016 ACS was $92,449. and that the unemployed proportion in that census tract was 0.05. So that's how you interpret the values of the variables that you've selected. So I'm going to go ahead and close this, and I'm going to look at the geocoded data, because the variables and the columns that are in the geocoded data differ from the ones that are in the point locations data set. I'm going to go back to the GeoMarker website, and I'm going to click on the download button and download the zip file that comes with that. I'm going to open that zip file, open the folder that's in the zip archive, and again, you see you have a codebook.txt and a CSV file that represents the data. I'm going to go ahead and open that one, and we'll go through the contents of it. I'm going to expand this again a little bit and then make these columns wider and easier to read. So again, let's orient ourselves with this data set and walk through what we have in it. So in this case, the first 5 columns match exactly the data that you uploaded to the system. So we've given you back the data that you uploaded. We then provide the latitude and longitude. These are the latitude and longitude values that were returned by the Texas A&M University geocoder. The geocode note column, column I, lets you know that the Texas A&M geocoder was able to successfully geocode the address that you provided. And then you have 2 other columns, column J, the NACR coordinate quality name, and the match type. And I want to talk about those 2 together, because they really need to be interpreted together. So the NACR coordinate quality name tells you the type of feature in the reference data that your address was matched to. So examples include address point, parcel, zip code centroid, or street segment interpolation. And address point is really the most accurate feature that you can match to. The address points effectively represent a rooftop accurate point for the address in question. So 630 8th Avenue Street Southeast, this pair of latitude and longitude coordinates will take you to the rooftop of the building that exists at that address. And that's what this address point references. The match type tells you whether the input address matched exactly with a record in the reference data set, or if the match occurred after something called address relaxation. So for 9 of the addresses that we have here, the match type was exact. So this address, 630 8th Street Southeast, Minneapolis, Minnesota, 55414, matched exactly to a record in the address point data set that Texas A&M has access to. For one of the records, 4700 Cedar Avenue, you see that it matched to an address point successfully, but that the match type was relaxed. In address relaxation, part of the input address, either the street, either a directional, north, south, east, west, or a suffix, that'd be avenue or the street, would be dropped, and the remainder is matched to the reference data set. So in this case, maybe in order to match it to the address point, maybe 4700 Cedar, Minneapolis, Minnesota, 55407, matched exactly to a record in the address point. That's what we kind of see with the value of relaxed. But again, the match type here needs to be interpreted with respect to the coordinate quality name value. So for example, you could match exactly to a zip code, which is an exact match, but if you provide an address and it couldn't match the address, the zip code may be a less accurate geocode, even though you did get an exact match. starting in column K and moving over to column P, you see the same set of geographic identifiers that were provided in the point locations. These are come off of the shape file that we overlaid the points with. And finally, the last 4 columns in this data set are the census attributes related to the variables that you selected. So GM10 is the housing units per square kilometer, and GM9 is the population, persons per square kilometer, so on and so forth. If we look at the codebook that goes with the geocoding output, it too looks a little bit different than the one that we had for the point locations workflow. Again, the structure is the same, the contents are a little bit different. So we have a data summary, we provide a data dictionary, we provide the contextual variable description, then we provide a description of the geocoding process and the geocoding quality field values that you may find in the data set that you've created. So if I scroll down here, we've got our data dictionary provides the geographic unit identifiers, the contextual variables that you may have chosen, and the geocoding results that were returned by Texas A&M University. And those include, as I mentioned before, the latitude, the longitude, the coordinate quality name, which is really the type of feature that the input address was matched to, and the match type. So if we scroll down a little bit farther, you'll see the contextual variable source data, same as we saw before. A description of the geocoding process, a description of the point and polygon process, and finally, here you see the NACR quality name values, address point, parcel, street segment interpolation, street centroid, address zip centroid, city centroid, or state centroid, and descriptions of what those mean. And we have some details about match type, exact, relaxed, soundex, or substring. And in the testing that we've done here, as we've started to set up this platform, we've had incredibly good luck getting exact and relaxed matches. And in most of the data that we've tested with, we've been able to match to address points, parcels, or street segment interpolation. So now I'm going to go back to the PowerPoint presentation and talk through tips and tricks, and then I want to open up the floor to questions and answers that you may have had. I'm cognizant of the time. It's 11:45. We'll have time for Q&A if you have them. So tips and tricks to using GeoMarker. Probably the most important aspect is that the quality of the address data that you're uploading to GeoMarker is key. If you provide poor quality addresses, they are unlikely to geocode successfully. I'm going to talk about the second one in a second. If you have a large data set of addresses, consider geocoding a sample first, just to make sure you're getting the output that you're interested in. Right now, GeoMarker is not the fastest web application in the country. So if you uploaded, a data set of 10,000 addresses, it will finish, but it may take a few hours to process. So if you want to test out the system, we recommend geocoding a sample first. And the second bullet point, input data should have no blank rows or lines at the end of the file. I mistyped that, I'm sorry. Our system will error out if you upload a data file that has extra empty rows at the end. So let me show you what that looks like. So this is a text file. This is actually the address text file that I uploaded. And you can see here at the bottom of this text file, there are three rows that have no data associated with them. If you upload this data file to GeoMarker, the system will say error and it will not process the data file at all. So if I were going to upload this data file, I would want to delete these extra rows, save the data file looking like this where there's no blank lines at the end, and then upload that data file into GeoMarker for it to successfully run. The next version of GeoMarker will hopefully have error handling for that type of use case. But for now, just know that you will receive an error if you upload a data file with empty rows at the end of the data file. And before we open up to the Q&A, I just want to acknowledge a number of people who have helped make this project possible. A number of our IT staff and software developers here at the Minnesota Population Center, and our ops people who have been incredibly helpful in getting this web app up and running. Peyton Baldridge works at Texas A&M University's Geoservices Center and has helped us get all the geocoding pieces put in place. And the center grant that funds the Minnesota Population Center has provided some support for GeoMarker. And I want to leave you with a few resources. The link to the website, geomarker.ipums.org. The second link on this slide is to the Texas A&M Geocoder. If you want to learn more about their data processing platform, you are free to use this link to go visit that. We have a user support email address on this slide so that you can send us questions, comments, feedback. This is a very new product. This is kind of the debut of it. And so we're looking for user feedback on where to go next. We will be sending out a link to the slides that we've put together here to all the people who have registered for this webinar. And we will be putting a video of this webinar up on YouTube, and we will provide you with that link as well in case you want to go back and check out another portion, rewatch part of the webinar, or if you're a professor, you may want to assign your students this webinar in the spring semester. That would be great, and feel free to share the video with anybody who you think would be interested. So with that, I am going to stop there, and we can move into the question and answer portion of the webinar. And if once we go through the Q&A session, we will come to the end. So Tracy, has anything come up from a Q&A perspective?
Yeah, we do have a couple of questions here. One user asked, if we have zip codes only, do you recommend using IPUMS GeoMarker, or is there some other way to get zip code level contextual variables?
So if you have zip codes only, you can use the IPUMS GeoMarker, but for right now, you will when it geocodes, we will return the latitude and longitude for that zip code, but we will then attach the census tract that falls at that point. So you'll get the contextual data will be tract level for that zip code. So for right now, GeoMarker is not the right product for geocoding and getting contextual data for zip codes. I would recommend looking at the IPUMS NHGIS product. We provide zip code level contextual data there, and you may just need to do a join or a merge for that. But if zip codes are something that people are interested in getting contextual data from GeoMarker, we will definitely put that on our list.
We've got a couple of questions coming in right now. A question that was asked earlier, is there any thought to creating an API for this service in the future? So
that's an excellent question, and we're definitely thinking about creating an API to this service so that you could call it from R, from Python, or from some other programmatic perspective. Here at the Minnesota Population Center, we are embarking on a API design and platform, and so we're definitely thinking about that. I don't have a firm timeline for that, but it's definitely something on our radar screen.
And we've had a couple of questions about, is there a maximum number of records you can upload at once?
And so it's better to be safe than sorry. Let me say that much. So if you have a very large data set, if you have 100,000 records, theoretically it's possible to support that. You may want to break that up into pieces just so that if something does fail, you can at least get some of the records geocoded. But theoretically, there's no limit on the number of records that can be geocoded. But for now, maybe keep it in chunks of, I don't know, 10,000, no more than 10,000 per data file, just to be on the safe side. The other thing I'll say is right now we have kind of a single queue. So if you have a large data set that's in the queue, we process them one at a time. And so anybody who's after you in the queue may have to wait a long time. So to kind of be fair to other users, maybe make the individual data files a little bit smaller.
Right, and then I think one more question maybe. Oh, and just a note, I'll handle this one. There's been a couple questions about the cost, and this is a free system. So it's free for research and academic use. So there's no cost for geocode or for anything else.
Correct, that's right.
And then another question about missing data. Will the system allow importing records with missing data in some fields, and how would that affect geocoding? So
the system will allow, so if you're missing a zip code for a record, or you're missing the city or the state, the Texas A&M geocoder will handle those records. But what would happen in some of those cases is you may get a poor quality geocode. So for example, if you have a street name and a city and a state, but you're missing a zip code, it may not be able to successfully match to an address point or a street segment interpolation. So you may only geocode to the city centroid or the county centroid, but it will handle missing data in that way. It will still give you a geocode. It's just that the quality or accuracy of that geocode may be lower than you would like. Tracy, any other questions coming in now, or? I think we've answered all the questions that have come in so far. Okay. Well, I want to say thank you to everyone for attending this webinar. Hopefully it's given you an introduction to this new product, IPUMS GeoMarker, that we are excited to introduce. And I urge you all to feel free to test it out, try it out, and send us feedback. geomarker@umn.edu. And we are super excited to hear the types of things you're interested in seeing us add to GeoMarker, or what you'd like to have it do. Again, the more users we can get for GeoMarker, that will prove to our funders that this is a product that is vital for the research community, and so that we can continue to get more funding to support GeoMarker's development into the future. So thank you all for coming, and again, I will send an email to all participants and registrants. I will send the email that has links to the video and links to the slides so that you can share them with others. Otherwise, thank you, and enjoy the rest of your Friday wherever you are in the US or throughout the world. Thank you, and thanks Tracy, and thanks Jonathan for chatting and handling questions in the chat and the Q&A. All right, bye everybody.